This is week 4, rule 4. Right now, the big buzzword through global transformation within our built environment is IDD, Integrated Digital Delivery Methods, which is integration between design, digital manufacturing, digital construction, and digital asset management. The four that I've just mentioned prevail very much still in a traditional style on projects, and they don't collaborate or connect easily when it comes to people and software and the processes. But before we discuss IDD, the challenge within our industry right now is to focus on planning. And from what I've seen in BIM projects in my previous experience, there's still very much poor planning around the digital implementation. This week's rule is about pragmatic planning, and we're going to be discussing the importance of classification standards within BIM projects. Now, to fully understand the need for data and information exchange within this architectural, engineering, construction, and operations environment, there needs to be a consensus within the industry. We need to conform to these certain standards. And the standards that I'm referring to are the classification of data within BIM models. We need to agree that every stakeholder in this industry has an important role to play. And from my experience, the software vendors will always be the gatekeepers to the advancing technologies, and possibly the data too. Now remember, they sell the software and they provide the training of this infinite technology. But regardless of their stance or anyone else's within this industry, we all need to understand the importance of data while remaining pragmatic about it. But when we discuss classification schemas on projects, the software only manages and organizes the information. We still need to capture it, and there needs to be a human intervention required before we start speaking about AI or technology that needs to play its part. And for those who have used or understand these classification schemas that are currently used on projects worldwide, we're faced with these various challenges, specifically in the design stages, where we talk about levels of development or LODs. There's still many designers out there and other professionals who have not yet understood or grasped the concept of these classification schemas. Yet, they still talk about BIM on their projects. What's the value in that? These schemas are developed to help organize things or objects more appropriately across all sectors of the industry. They're not only a system, but they also define BIM objects in a digital asset. Call it a digital twin if you want. By standardizing this information, it simplifies the collaboration between architects, specifiers, contractors, and other suppliers across the team. It also helps estimators and quantity surveyors understand their quantification requirements, as well as their timelines and their feasibility budgets. If we're going to talk about standards, in particular, I'm going to refer to the ISO standards 12006, which is the framework for classification, and it's well known on projects across the globe. One could also define the classification system as an infinite standard that helps systems sort out data as well as objects, so that the other stakeholders on the project can now identify components and make use of the data that's within those objects or elements. In a recent post of mine, I spoke about the finite player versus the infinite player within our construction sector. And I explained the challenges that we face when these two clash within our industry, where I see the technology being the infinite player and all too often people are the finite players. There's still very much traditionalism or the misconception about BIM within our industry, and it prevails deep down into the different sectors. And each and every one of us is not only fully responsible to understand the benefits of digital transformation, but we also need to understand the needs of others when dealing with this information exchange within projects and beyond. But this rule is not about ignorance or naivety. It's about the importance of understanding how we classify things uniquely, or how we structure information, not simply as a system or an object, but also to understand the classification of information that acts as a functional specification system. And this helps project teams with other features, such as cross-sector information management, where we combine buildings, geography, and infrastructure. It also helps us manage the full asset management lifecycle when we look at facilities management and the development and the planning of smart city developments. And finally, we look at the integration of cross-sector software systems. Ross Griffin is in Copenhagen, Denmark, and he's an experienced senior cost specialist with demonstrated history of working in large-scale projects. And as a skilled cost manager, he shares his views on the challenges that he faces when it comes to ticking the box with levels of development and how he has to do cost reporting, procurement strategies, and overall commercial management within a BIM environment. Let's hear what Ross has to say.
I just want to talk a little bit today about pragmatic planning and BIM for quantity surveyors. There's a lot of talk in the industry at the moment about BIM and its development and the progress that it's going through, as well as the benefits that we will see over time from BIM. But I think there's a little bit of a misconception when it comes to quantity surveyors and BIM. We hear from the industry that we believe that certain parts or tasks of the quantity surveyor cost manager will be replaced by BIM through automation and whatnot. But let's dig into that a little bit today. We all know what the LODs, level of detail, are relating to BIM. At the different design stages, we have different LODs coming in terms of the information and the detail within the 3D models coming from the design teams. But while we have and can comply with the LODs, the issues that we have around LODs is the quality of the information relating to the LODs. And this is what we're kind of going to talk about and discuss today, is how can we ensure there's quality and value within the design information and the level of detail, the LOD, that in the QS can use in order to build their cost plans or bills of quantities or what have you. Another thing we're going to look at, of course, is coding structures within BIM and how the QS works with their coding structures and the standards that they have. The final one is collaboration. All of this comes down to a quality level and a value level within the BIM process and the 3D process. But let's look at LODs to start with anyway. Right now we run through different stages of the design, and we have requirements that design teams have to deliver to. These are dictated in the tender material and contract requirements, as well as the ICT agreement. So LOD 100, 200, 300, 400. And within these LODs, there's particular requirements of information. The higher up the LOD number, of course, the more information that should be within the design and 3D material. This means that the objects become more smart and full of information. But what the LODs don't talk about is the quality of that information, how we can use that information in order to extract quantities, but also extract information, how we can use that quality and information to develop our cost plans and cost estimates, or from the contractor's perspective to build and order materials and build on site. And this is something that we're missing, because right now we're box ticking that we have delivered a project to an LOD 300 or LOD 200, but what we're not actually looking at is the quality of that information internally. Design teams, architects and engineers are of course producing the information that they feel is necessary in order to deliver the project, and that's design information for a design output. So right now today, I suppose our output is still the 2D drawing aspect, even though we deliver either the IFC and our Rivet files as part of our delivery. But within the ICT agreements, what the LOD requirements don't say is the quality of that information. How should it be used and how can it be used, and what are the minimum standards within that quality of information, the information around each of the objects, and how that information is going to be used at each of the stages. So there's a gap, I think, here between how information is used, how we prepare that information, and how it should be delivered. And today, as QSs, the traditional way of working is that we wait for a design team to deliver the project to us at each of the stages. We carry out our cost planning tasks and our tender material bill of quantity tasks, and we deliver. The issue that we have now is that that process can't continue, because the fundamental fact is that the design teams don't know what information is of value to us, and we don't know how the design teams actually prepare their 3D models and 3D information. So all of this is connected with a new way of working, I think, and how we're going to restructure our professionalism around the delivery of design information and design material. And the accuracy, of course, the output of that is the accuracy of the information, and the accuracy of our cost planning, and the accuracy of our bills of quantities. And this is a big challenge, I suppose, because we're really looking at changing how we work from a QS perspective, but also changing the understanding of what good value and good quality information actually is from a design perspective. It's not just showing you what it is that the design intent is. It's actually looking at the information that's included in the models and saying, is that of value to us or not? Should we be putting that in there or not? And unfortunately, as I said today, the design teams just don't know, and we need to get up beside them and work with them as QSs in order for us to be able to influence the design information, the quality in the design information, and what we believe is necessary to do our job. A lot of talk is about also the coding structures, uniclass, omniclass, these type of coding structures, as well as the quantity surveying standards like ICMS. What is that? How does that fit into this whole BIM world? How does that fit into the design process? Who controls this? What does it look like? And then we have what we need to understand about ICMS actually is that it's not a quantity measurement and pricing standard, it's just a cost breakdown structure. Only a cost breakdown structure to a certain number of levels, 4 levels. After that, you need to take your method of measurement and pricing rules and then do your quantity extract and build your cost plan and your bill of quantities on top of that. So that's very important. Today, the RICS and some organizations have mapped ICMS to uniclass, for example. Albeit while that's very good, that still doesn't give us what we need as an output from BIM as quantity surveyors, because again, that's only a level 4 deep information level. So for example, we would be able to identify foundations but not the concrete reinforcement formwork. So for example, we would be able to identify foundations but not the concrete reinforcement formwork excavation to those foundations, because that's the measurement and pricing rule. So here we begin to look at the different standards that we have and how they're all connected, and are they actually connected.